7.5. We use our model, we let x equal 7.5 plus 38.57, and we would get 64.3. Thank you, Daria. I got it this time. Next time, have to tell me to plug in my cables not plugged in right. Okay. Okay, questions on number 3, or that's 4. Okay. Okay. On 5, I have a lot of people have issues with this. I even had an instructor tell me it was wrong. And the problem they were having with it is the way it is written. Remember that time does not have to be, it can be in decades. Okay? It's saying change per decade. So all we have is our initial amount. This is an increase, so it's 1 plus 0.12 to the t. Okay? Now, from 2000 to 2010 is 1 decade, 10 years. So that's 1. If it was 2020, it would be 2, and so on and so on. So Erica, are you okay on that one now? That would be A. No. The initial amount, the starting amount, was 86,500. You've got your formula on your formula sheet. I just use initials. You've got an initial amount, then it's 1 plus a % increase or minus a % decrease to a time period. Okay. The starting amount in the beginning was 86,500. So that was the initial amount. Okay. It grew 12%, so 1.12, 1 plus the 12% to the time period. It's just asking which represents the population change. So we don't even need to use this. We can check it and see if it works. It's 1 decade, so if you just multiply that out, we should get roughly that amount. And we do. Okay. Okay. 6. According to the 2010 census, the population was 96,210. A 23% increase from this 78,219 in 2000. Construct an exponential model to predict the town's population each decade. Use the model to predict it in 2050. Round it up to the nearest person. This was the one the instructor had the problem with. So what is our initial amount, the very beginning? Is it this amount or this amount? What did we start with?
$78,219.
Good. And we know it's exponential, not linear, because it's a % increase. That's why we're using the exponential formula. It's an increase, so it's 1 plus, make that percent a decimal, 1 plus 0.23 to the t, and t equals the number of decades. Okay? So now we're using it to predict the population in 2050. How many decades, number of decades from 2000, because our starting point was in 2000. How many decades is 2050 from 2000? If we've got 2050 and it started in 2000, how many decades? It's 5. Yep, t equals 5. So all we do is plug in a 5 for t, and then I think it said round up, not round to the nearest number, so we're not going to keep it at 10 even though it's a 3. When it says round up, we'd go to the next number, so it'd be 220,211. Make sure you're making it an exponent. It can't be times 5. That's got to be the exponent. Mine is the caret key right here. Okay. Questions on that one? The population of a certain species of frog grows at 13.1% every year. That's telling us it's exponential growth. Initial amount times 1 plus, this is a growth rate, so that'll be 0.131 to the t. And t is going to be in years. Suppose 42 frogs are released into a pool. Consider an exponential model to predict the population of frogs. So A would equal 42 is the initial amount, 1.131 to the t, so it would be C. Okay, makes sense? 8 years means we would let t equal 8. That's just, remember to make it an exponent. So up to the nearest frog would be 113 frogs. Questions? Okay, you guys try 8.
When you asked if anyone had any questions, I almost asked if you preferred rounding up to the nearest frog or a panda.
Is this the panda question?
I had one. I had a panda
Yeah,
question.
this one is the panda question.
uh,
And this one gets confusing because they put the 1 in there already. You don't have to add the 1. They gave you the growth. They didn't give you the percent increase. That throws people off. So that 1 is already added in. This is a percent increase. That's when you have to add the 1. This one is the population growth, which has the 1 added into it. Okay, so we started out with the 30. The 1 is already in there. Annual means years, so T is going to equal number of years. So our answer is C. So how many years will 1995 be? From 1981. And this one is rounding up again, so I don't think I've ever seen a panda in real life.
San Diego Zoo.
Never been to San Diego. All right. Yes, I see pandas are on your quiz. You have that same question on your quiz. Okay. Okay, 26 or 28, your last homework of the year. It works the same way, it's just with decreasing. The half-life of a radioactive substance is 1 day, meaning that every day half the substance has decayed. Suppose you have 500 grams of the substance. A half-life would mean 100% minus 0.5 or 50%. So it would just be 1 minus 0.5. So all we get is the 0.5, but I see they are using 1/2, which is the same thing. So it's our initial amount times 0.5 to the t, but they used 1/2. So we have 500 times 1/2 to the t, which is A. Now I'm going to just use 0.5 in my model. Be easier to put in the calculator. T equals 6. And we get 7.8, and that was grams. This problem has always disturbed me. This is an example of somebody trying to make a problem into real life that shouldn't be. We would have no tortoises in the world if it were true. Because think about what it's saying. Suppose a tortoise is 1,800 feet from the ocean. Each day the tortoise travels 1/4 of the remaining distance to the ocean. That means they would never reach the ocean. Which of the following models could be used to predict the distance that the tortoise must travel to reach the ocean? Okay, so we have 1,800 is our initial amount. It's a decay of 1/4. So 1 minus 0.25, or they're going to use 3/4 I see there. So what's going to be left is 3/4 to the t, but I see they're using x, so it is b. T is going to equal 4 days. I'm going to put 0.75 into the fourth. You can use a fraction, it would still turn out the same. And that poor turtle still got 469 to the nearest tenth, 0.5 feet. But like I said, the sad thing is they would never reach the ocean with that formula. Okay. Questions? Like I said, it's working the same way. It's just a decay. Let's see. How about number 3 is like a quiz question. Number 4 is one most people have problems with. Anybody need help with 4? Atmospheric pressure decreases by 10.3%. That's not a hard part. That's showing you it's exponential and it's a decay, so it's 1 minus 0.103. Which will be 0.897. This is the part that gets them. T equals every 1,000 meters. That is the tricky part. The initial amount at sea level is 1,013. Okay, so A equals 1,013 times 0.897 to the T, and T equals every 1,000 meters. Construct the model of a given altitude in thousands of meters. Use your model to determine the pressure at an altitude of 2,800 meters. So this is where you run into trouble. If it's 2,800 meters, T is per every 1,000 meters. You've got to divide by 1,000. So T is going to be 2.8. That is where most people get stuck. We get 747.2. Does that make sense now? Okay, anybody want 5? Okay, the reason I'm doing this is while this one tells you to construct an exponential model, on the test they might not tell you if it's exponential or absolute. So I'd want you to get in the habit of making an absolute and relative, and this is going to start to tell you, if you do all 3 of them, looking at the relative that rounds to 0.35, this is telling you that it's exponential. Okay, so even though this told you, I wanted to try and show you, in case it doesn't on the test, how making these 2 yourself will help you in that direction in case they do that to you on the final, which I'm telling you they might. So if you just see these 2 columns and you don't know what to do, make these 2, cross out the first one, determine which it is. Okay? So now we can write the formula. We know it's exponential. What is our initial amount? Somebody's got an idea. Where does our initial amount come from? Erica says 525, and she is absolutely right. And then this is a decay because it's a negative. So it's going to be 1 minus 0.35 to the t, which are hours since the drug is administered. It's going to be A equals 525. 1 minus 0.35 is going to give me 0.65. And it says 7 hours after it is given to the 7th. And we get 25.7. Can you do the ratio where? I'm not sure where you want to do the ratio. You can't do the ratio for the exponential growth. That won't work. Do you mean the ratio up here to find the relative change? That would work up there. But you would need to check more than one, if that answers your question. Because you can't just check between 2 of them. You got to make sure it applies to several. I don't know what the ratio. You'd have to tell me what you're talking about, because it's got to be to the 7th power for the 7 years. You'd have to show me how you're taking it to the 7th power. Or you mean to get the decay factor. You might be able to do that up here. Okay. I know what you're talking about. Yes. Are you talking about just taking these two numbers right here and here? Yes, you can. Absolutely. Okay. You can do it from here to here and here to here to get the number without, and then you don't put the 1 in. You can do that. I know what you're talking right in here to get that number. Yeah. Okay. All right. The last one here, 180 milligrams is given to a patient. It leaves the body at 6%. So leaving the body would be a decay, 1 minus 0.06. Construct an exponential model to represent the number of milligrams in the body T hours after the dose is given. So A equals, our initial amount is 180. 1 minus 0.06 would be 0.94 to the T. What is in the body after 10 hours? To the nearest tenth, that would round up to 97 milligrams. Okay. All right. Some from your quiz. A certain vehicle loses 44% of its value each year. This is telling you it's exponential decay. 1 minus 0.44. If the initial value, they even use the word, is 39,140, we just did 1 minus the decay is 0.56, and to the T, and T is going to equal 7. Just a straightforward one here. Okay. Any problems with that one? Got time for another one? Looking at those pandas again. I think we just did one like that. So which one would it be? A, B, C, or D? Already got a B there. Anybody agree with Bridget? Initial amount is 25. They gave you the growth rate, so you don't have to add the 1. So she is absolutely correct. the half-life of a substance is 1 day, meaning that every day half the substance is decayed. 73 grams, construct a model. How much will you have left after 2 days? Well, that's too easy. You could do that without a model, but what would the model be and what would the answer be? Anybody got it? I'm sure somebody does. Bridget does. 750 to the 0.5 to the t. Oh, 730. So 730. And then the answer would be, for 2 days, would be what? I agree. To the nearest tenth, so 182.5. Probably the trickiest one would be number 1. Which one could be a model of exponential? Which one of these could be exponential? And how do you know? This goes back to what Fatima was talking about, the ratio. If you know it's exponential, you can find the ratio real easy. All you take is the new and divide it by the old one there, and you get the ratio. 3.25 divided by 3. That gives us 1.083 repeating. 3.5, now we do this one, divided by the previous. I got something else, so that tells me this is not exponential. They would have to be the same. And what Fatima was talking about earlier on this one, you can know it's exponential. Where'd it go? Really quick, if you know it's exponential, all you have to do is this divided by that, this divided by that, and you will get, oh, it's not that one, somewhere. Where'd it go? I don't know where it went. Right there it is. If you divide the new by the previous and they all come out the same, that is your exponential growth right there, or decay. But then you don't add the 1, so that gets some people confused. Okay. So then if you do these, 3.75 divided by 3, so then I keep checking. this one divided by that one, 1.25. Only one more to check. And that one works. Okay. 1 divided by 0 is 0. 3 divided by 1 is 3. So I know that one doesn't work. Okay. So does that make sense? Any questions? I think I probably ran over time. I did. That is all for the whole year. I will do the test reviews. Along with the test reviews, I've gone through the test and there's 2 or 3 questions that I think you need to pay careful attention to, and I've made those extra ones and we'll do those during the review. So please come to the reviews. If you can't, watch the reviews online for those extra questions that are not in your review that you want to pay particular attention to, that I want to make sure you get and practice. Questions? Sorry about the power. We haven't had too many problems this semester. Is anybody out there?
Yes.
Okay, Tim, hang on and I'll pull your screen up. Anybody else that has anything can hang on?